start. So this is going to be a review of for your quiz on Thursday. Okay? You have a quiz on Thursday, right? لا بس
Happens to the best of us.
Huh?
Happens.
This is the worst time it happens. طيب, you have a quiz on Thursday with the professor, right?
Yes.
Yeah, just this is a review. So, I'm gonna start with 10.1. It doesn't have a lot of content here. We're gonna do graphing of parametric equations. Now, there are two ways to graph parametric equations. But before that, let me remind you what parametric equations are. In calculus 1, we learned this type of function. For example, we took y equal f of x, or x equal g of y. Okay. Now, what we're gonna do? Now, what we're gonna do? We're gonna have a function y equal f of x transformed into a system of equations x equal f of t, y equal g of t. These two are related, okay? But they are indirectly related through the variable t, okay? Or we call it, how do we call t? Parameter. Now when you graph, you don't graph on the tx something axis, no. You just graph on the xy axis normally, okay? So let me give you an example. Graph the following function. X equal e to the t, y equal e to the minus e to the t. Okay? Now, one way to do it is what? Is you make a table and you plug t values, and then you get x and y coordinates, and then you plug them together. This is one way of doing it. Another way of doing it, which is more efficient, is that you eliminate t. So you write the equation in terms of x and y. And how do you do this? Through some algebra. Okay? So let me, for example, solution. I can write y as e to the t power minus 3, right? Just taking this outside. But what is e to the t? It's x. So technically I'm talking about x power minus 3, which is basically 1 over x cubed. So this question is identical to this problem. Like, as if someone told you, come and graph 1 over x cubed. Okay? That's the idea. Right? So, and then how do you graph this? Anyone knows? How do you graph it? It's going to be like this. Something like this. Okay? Now, similar to 1 over x. Let me restrict t to be larger than 0. Okay? Now, this is not enough. Parametric equations, they provide a direction for the curve. So you want to tell me, is the curve going like this or like this? I don't know. So where is the curve going? Now, how do I know that? I can plug t and see what I have, right? So plug t equals 0. What do you get? You get x equal 1 and y equal 1. So at t equals 0, the graph starts from 1, 1. Let me make it here, for example. Here, 1, 1. This is the first point on the graph. And then,
Professor, where do you plug t?
right? And then you get the pair. So basically 1, 1 is a pair on the graph. And it's the first pair because t starts from 0. It's larger than or equal. Okay? And then I can say plug t equal infinity. So what do you get? E to the infinity is infinity. And then e to the minus infinity is 0. So you're telling me x is going to infinity, which is what's happening here, and y is going down to 0. And that's what's happening in the graph. So the graph starts from t equals 0 and then goes like this. It doesn't go backwards. So here. Okay? Good. You can look at other questions where they, for example, provide you can like sketch with a table. Okay? You can make a table, plug certain values of t, you'll get some coordinates and sketch like this.
Why did it start at 1?
Why does I decided t to start from 0?
Oh.
Okay? That's it. طيب. Next. Now what's more important here is 10.2, which is calculus with parametric equations. Okay? So what did we do in calculus 1? We did first derivative, second derivative, slope of tangent line, these kind of things. Okay? So we're gonna do them here on parametric equations. So the first derivative is gonna be dy dt divided by dx dt. Okay? And the second derivative will be, here you have dx dt, and then you have d dt of dy dx. Maybe this notation is confusing, but when we solve a question, I'll clarify it. Okay? So let's take an example. Find find dx dt, dy dt, dy dx of the following. Okay. How do you find dx dt? What does dx dt means? Go to that function x and differentiate it with respect to t. Okay? That's it.
So it's 1
Hmm?
What is 1?
What's what? 6t plus sine t. Okay? Okay. dx dt means again, go to the function x, differentiate it with respect to t. So what do I apply here? I have to apply product rule. So I have 4 e to the t plus 4 t e to the t. Okay. And then dy dt, the same thing. Go to the function y, differentiate it with respect to t. So what is it? 6 plus cosine t. And then he asked me for dy dx. Go to the function y, differentiate it with x. There is no x. But it's like, there are x's inside this t, but you don't know what they are. So what do? You just use this formula. Okay? We already computed dy dt over dx dt. He doesn't have to tell you to compute them. Okay? Is it clear? Is the class hot or not?
Hmm?
The class is hot.
Yes.
Let's open the door.
استحينا نتكلم.
What doesn't work?
Okay, one more example. find the equation of the tangent line of y equal tangent line equation. Does anyone remember the tangent line equation?
Slope.
What is the form?
Y minus y1 equal m.
Yeah. Y minus y1 equal. Yes.
M into x.
Huh?
M into x minus x1.
How do I get y1 and x1? Speak.
Plug T minus.
Plug T.
Leave t minus 1.
Right? Okay. So plug t equal minus 1, you get what? Y equal 0 and x equal 0. Okay? So that's like y1 and x1. What is m? Does anyone remember m from calculus 1?
Slope.
Slope is the derivative of the function. So m dy by dx.
Professor,
Yes.
isn't y supposed to be 2?
2
Because
minus 1 power 10 is 1, and then plus minus 1 0. What do you mean? Yeah? dy dx. How do I find dy dx? Right? So what do you do? dy by dt, go to y, differentiate it with t. 10 t power 9 plus 1, 9 t power 8, and that's it. Okay? Here dx dt. And then you need to plug the point. T equal minus 1. So how much do you get? This is minus 9 over 9, that's minus 1. So finally, y minus y1 equal m, x minus x1, so you're telling me y equal minus x. Any questions? Here? Okay. Let's do one. Again, same that example, okay? So find just a different function. Tangent, line, equation of x equal 6 plus ln t, y equal t squared plus 6. Okay? And then he gave you what? He gave you also the point. So the point is 6 and 7. So he gave you x1 and y1 in a way, right? Not t. Okay? Gave you x1 and y1. Okay, so what do I have to find then? The slope. What's the slope? Which is dy dt divided by dx dt. Right? Which if you simplify, you will get 2t squared. I need to plug the t, right? How much is it? He didn't give it to me.
It's not real.
طيب, can we...
Can block y, 7 equal t power 2 plus 6, so we can find t.
Yeah. Okay. Yeah. So you can find t by plugging one of them here. Okay. You're just gonna tell me to find t. 7 equal t squared plus 6, t squared equal 1, so t equal plus minus 1. Do I take the minus or the plus? And why? Why?
Because len
About.
doesn't exist.
Because when you plug it in len doesn't accept minuses.
It's not because of the bounds.
There's no bounds.
6 and 7.
This is x and y, not t. This is not a bound, it's a point. X is 6, y is 7. Okay? So take t equal 1. Because t equal minus 1 does not work in x. Len of minus 1 does not exist. Len of any negative does not exist. Len of 0 does not exist. Anything from 0 to negative infinity does not exist in Len. So this is positive 1. Here you have 2. This is this one. Finally, y minus y1 equal m x minus x1, and then you simplify the equation. Okay?
What if the equation we have it accepts minus and plus?
No, it's impossible. Now, okay, what if it accepts? Yeah, I get your question. Then, if you plug that minus in here, you have to get 6. And if you plug the other value, you get something different. You get me?
Yeah. So
Okay.
I take the value I have.
Yeah, exactly. So you need to check, is it matching? Yani for example, if the minus 1 works, plug it here. If it gave you 6, then this is the correct t. If it doesn't give you 6, then the other t is correct. If you want to avoid all of this mess, you can, another way to do it is you can write y in terms of x. I can eliminate t and write y in terms of x and take the derivative. I can do that. Actually, this question, if you look at the practice sheet, it's solved in the 2 ways. They didn't eliminate t and they solved like this, or they eliminated t. Yes.
Is it called eliminating the parameter?
Yeah.
That's what we did.
Yeah, but eliminating parameter means cancel t and write it y in terms of x.
So we can do that here, or we could do it.
You could technically you could do it anywhere if the algebra works. Like if the algebra is nice. Here I think it works as well. If you let's try it quickly. So what do we have? X equal x minus 6 equal len t. So take e to both sides like this, and then plug it in y. So y equal e to the x minus 6 squared plus 6, which is e to the 2x minus 12 plus 6. That's one. And then you want to take the derivative of this, right? To find the slope, for example. So what is the derivative of itself times the derivative of the power? And then you plug the x value, right? Oh, wait. No. And then x equal 6. So you get 2. See, same answer. So this is another way. Is it clear? So you choose whatever you want. If it works, it works. Okay. Sometimes eliminating t doesn't work because the algebra is too much. But sometimes if it works, you can do it. Okay. Just a couple of applications here. But let me do a question in second limit. So x equal e to the t, y equal t e to the minus t. So find dy dx and the second derivative. Okay. What's dy dx? It's dy dt. Differentiate differentiate this with respect to t, so you get e to the minus t, e to the minus t, and dx dt is just itself. Now we need to move to the second derivative. But before doing this, I would suggest that you try to simplify this as much as you can. Okay? Because if you didn't do that, second derivative will be a little tough. So I can pull e to the minus t as a common factor and get 1 minus t. Okay? And then I can put this down. So what do you get? 1 minus t divided by e to power 2t. Okay? This is the first derivative. This is a much nicer form. Okay? And then I jump to the second derivative. Let's see how we find it. So let's read the notation. First, on the bottom I have dx dt. Just differentiate this, so you get e to the t. And then you have d dt of what? d dt of dy dx, which is what we just found. So I'm telling you here, differentiate the first derivative answer that you got divided by dx dt. Okay? So here I need to apply quotient rule. So here I have e to the 4t, derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Okay? What I can do now, I can simplify it a little bit. Let's simplify it because there is another part of this question that I want to discuss. So this will go here. Let e to the 5t, and then minus e to the 2t minus 2e to the 2t. Okay? So this is part A of this question. Now let me find the interval where the function is concave up or down. Okay? So go back to calculus 1. When is a function concave up and when is it concave down? It's concave up when the second derivative is positive and when the second derivative is negative, right? So this is the second derivative. So now equate it to 0. Okay, find like what we used to call inflection points, and then you plug them in the number line. Let's see. Okay, so minus 2 equate it to 0. Okay, and then solve this equation. Now a fraction equals 0 only if what? Only if the numerator equals 0, and this will never be 0, so you can just multiply it to the other side. Take e as a common factor. You have minus 1, minus 2, 1 minus t equals 0. Again, this is never 0, so you can divide it on the other side. So you get minus 1 minus 2 and minus t equals 0. Simplify here. So you get t equal to 3 over 2. This is the inflection point. Let's plug it on a number line. And let's test the sign of the derivative. Plug anything now. Plug 0 for example, and tell me, is the second derivative positive or negative? Let's see. If you plug 0, what do you get here? Here is 1. This is minus 2. So this is minus. Okay? And this will be, I think this will be plus if you put it. Okay, you can check. Yeah, it will be plus. That's it. So the curve is concave up on minus infinity to minus 3 over 2 and concave your applications here, and then I'll let you go. Rest area under a parametric curve. So A equals integration of y dx. This is the formula of it. But this can be simplified to the following: y of t, x prime of t, dt. This is what I need you to do. Okay. Second application is Rn L equal integration from A to B dx dt squared plus dy dt squared dt. Okay. And then I have third application, surface area around x-axis, sx equal integration 2 pi y of t multiplied by the arc. And then the fourth equation sy, surface area around the y-axis. If I rotate around the y-axis, so surface area around y-axis, 2 pi x of t times r from That's it. Okay, so let's have some questions on this. Find the area enclosed by, that's good. So let's apply it. What's the formula? Integration, the function y times x prime. Okay, so area equal integration, the function y, just copy paste it, sine t cosine t, multiplied by x prime of t. How much is x prime of t? 8 cosine t, right? Okay, that's it. And then the integration goes from 0 to pi over 2. You have 8 integration 0 to pi over 2 sine t cosine squared of t dt. How do I integrate this? No. They said chapter 7 is not included, right?
It's ideal.
The double reduction.
We expand
First, no.
Wait,
Cos square theta is interest for
Yeah, I think it works, but I don't want this.
Can you use the
There's
one?
something easy.
Cos 2t
One
minus 1
plus-
over 2.
Yeah,
No.
cos t. Yeah, cos 2t plus 1 over 2.
1 minus
You know what? Figure it out.
Oh, Yusuf.
Yusuf.
Substitution.
Yusuf. Sure, guys. Yusuf. Listen, they said chapter 7 is not included. That doesn't mean when I give you a question, you don't know how to solve it. You still need to know the techniques. I mean, they're not gonna like go crazy in the exam, of course, but it will be simple, basic stuff. Like, we're not gonna go improper and partial fractions and long division, these kind of things. No. But if I gave you an integration, I expect you to solve it in the exam. Okay? And this is what they're gonna do. You still have integral test included. You still have integrations in this section. You still have integrations in 10.4, or 10.3, the polar coordinates. So you still have to do integrations. You need to remember these. You need to remember substitution mostly. Telling you from experience, mostly substitution, maybe by parts like maximum, and then integrations involving the identity, things like that. Sine squared. How do we used to integrate this? We used to convert it, right? We used to say 1/2, 1 minus cosine 2t, and then we integrate that easily. This is appearing a lot in 10.3 and 10.4. Okay, I think you already took the sections, right? Yeah, no?
10.3.
Wallah? This week is next week is the last week of classes.
He said it will be enough.
I don't know.
It's not going to be enough.
We'll see. Inshallah khair. But يعني I'm warning you, substitution by parts. Okay? What is it? And the identity things. The sine square, cosine square. You know the trig integrations, but with the cases when both sine and cosine are even. If you go back to your notes, you will see what we used to do. Using the identities, the half angle or double angle, whatever you used to call it. Okay? So these appear a lot. You will see them in the final samples as well. Okay? So be careful. Still have to use it here and integral test in chapter 11. Anyways, so here's substitution, right? Minus sine t dt. Okay? So 8 integration. Sine t dt is just du minus du actually, so I'll put the minus out. And then this is just u squared. Okay? Cosine 0 is 1. Cosine pi over 2 is 0. So minus 8 u cubed over 3. From 1 to 0. Plug 0 you get 0, plug 1 you get 8 over. That's it. Okay? Let's do arc length or something. Find the exact length of is equal to over 3t cubed, y equals t squared minus 2, t is between 0 and 2. Okay? Apply the formula direct. L equal integration from a to b square root of dx dt. How much is it? 2t squared, right? So take the derivative. Squared plus dy dt squared dt. Expand a little bit. 4t power 4 plus 4t squared dt. He didn't say set up, he said integrate. How do I integrate this?
4.5.
do you want to take?
40 squared.
Okay. And take 40 squared as a common factor first. So let's do that. Is this what you're talking about? Now I have multiplication. I can distribute the root on multiplication, not addition. Don't come and tell me this is 2t power 2 plus 2t, okay? Don't come and tell me this is this, okay? You apply the root here plus apply the root, it doesn't work. This is garbage, okay? Please, don't. I know someone will do it one time. Fine. So you have, again, you can distribute the root on addition and multiplication division, not addition subtraction. So here I have 2t times root t squared plus 1 dt. Okay, this is good. Now what? Use it. I think clearly you can see a function with its derivative, right? So now what do? U equal and du equal 2t dt. Okay? So what happens here? Integration 2t dt becomes du and this is root u. That's it. And the integration will go from 1 to 5. How did I get these numbers? We just plug in. If t equals 0, u equal 1. If t equal 2, u equal 5. That's it. So just integrate. This is u power half, so it becomes u power 3 over 2 over 3 over 2 from 1 to 5, and then you just that's it. Okay? Whatever this number is. Just plug. Plug 5 minus plug 1. And the 3 over 2 is 2 over 3 if you look at it. Okay? Any questions? Okay.
Professor,
Yes.
can you do a question where we have to sketch the graph?
Sketch what?
Sketch the parametric curve?
Similar to the one I started with, you mean?
Yeah.
Let me just finish this one. I'll just do question on surface area and then. Set up an integral that represents the surface area around x-axis for okay. So what do I have here? What is surface area along the x-axis? Okay. Just find the derivative first. How much is dx dt? Apply product to sine t plus t cosine t. And how much is dy dt? Cosine t minus t sine t. Okay? And then put it in the formula. So surface area around the x-axis, integration 0 to pi over 2, 2 pi y times the square root here is the formula times the square root of dx dt squared cosine t minus t sine t. You said set up, so I don't have to evaluate. 2 pi, okay? Perfect. want to sketch this. Okay. Now here, it might be annoying to you if you want to do the algebra and eliminate t. So you could do this. You could just make a table. T, x, and y. Okay. And you plug some points between -3, following of course the range here. You plug some points between -3 to 3. So you can say -3, -2, -1, 0, 1, 2, and 3. Okay? So, like you can plug more if you want. Like, you know, you can plug -2.5, -1.5, and so on. It's up to you. Just plug a sufficient number of points if that makes you draw. Okay? So, I plug -3 in the x. What do I get? I get here 5, 0, -3, -4, -3, 0, and 5. All of these, what did I do? How did I get them? I plug these t here and here. Okay? Try it out. I don't think this is difficult to understand, to plug. Okay? And then here, the same thing. These guys, you plug them here. Okay? So what do I get? I have -18, -2, 2, 0, 2, 2, 8. And then I need to plug now. To plug, sorry. So you plug them one by one. Yani you plug, you don't care about the t by the way now. You plug the 5 and -18 now. You plug the 0 and -2. You plug the -3 and 2. So 5x and -18y here, let's say. Okay? 0x and -2y here, let's say. So the curve starts from here and then goes here, because it has to follow the t as well. This is the first t, it's -3 here. And this is the second one, it's t equal -2, and then so on. And then -3x and 2y, so here, let's say. Okay, again, -4x, 0y. -3x, -2y. Why is -4x and 3y here? Let's see. -3x, -2y, so here. 0x and 2. Where is 0x and 2y here? Then finally 5 and 18. How do you plot? You start from the first t here. So t equal -3 corresponds to this point. Then you connect it to the point corresponding to t equal -2. And then you connect it to the point corresponding to t equal -1. Where is it? Here. This guy. Just this guy. Okay? And then you connect it to the point corresponding to t equal 0 now, which is this guy. And then t equal 1, which is what? This guy, right? Here. And then t equal 2, which is this guy. And then t equal 3, which is this guy. That's it.
Do we have to check like concavity, inclusion?
No. They don't care now. And the curve starts from t equal -3 and ends at t equal 3. So this is the direction of the path. You have to mention the direction. They will deduct marks.
Just,
One second.
so it'll just be a rough sketch.
Yeah. Don't care about concavity. Yes. Try like a small range, -5 to 5, something like that. Okay, guys. Any questions? طيب. So this is the last week. Next week there's no recitation. I hope you learned something out of this. Okay. I might post recording for 10.3 and 4, and solving the final previous if you want.
Listen, there's complex numbers as well.
Yes.
What about the quiz?
What was?
Like, we just had one quiz.
You were here last time?
Just the review.
You were not here? والله راحت عليك.
Huh?
We did the quiz last time.
Really?
Yeah.
Listen, you didn't send any of that.
لا ما هو it was the evaluation.
I I knew it. I did that. What interviews?
Huh?
Huh?
The course evaluation. We agreed last time that there is no quiz.
Okay.
And the bonus was the evaluation, that's it.
Okay, I knew it.
طيب. inshallah. طيب. If you still want to do a quiz, I'm doing a quiz for your section.
My section?
Yes.
Tomorrow?
Yeah.
Really?
Yeah. Okay. On 11.11. طيب anything else guys؟ خلاص؟ طيب يلا. Good luck.